Good morning, scholars. This is Mr. Lowe. I'm bringing you your audio lesson for the start of Unit 4, Quarter 4 material for quantitative literacy. We're going to start Unit 4 by studying a little bit about matrices. So we're doing a unit on matrix algebra. It's a subset of finite mathematics, which is taught primarily at the college level for those students who are not entering into a technical mathematical major. It is somewhat taught in some high schools, especially at the Algebra 2 level, but for the most part, it's not really in our curriculum, but it is in ours. So let's go ahead and get started. So the basic concept of a matrix. If you worked with a table, you've worked with a matrix. A matrix is a rectangular arrangement of rows and columns. So you may have seen a matrix before, just haven't called it that way. The number of rows and columns of a matrix are known as its dimensions. Known as the dimensions of a matrix. Dimensions are also known as order, could be known as size, just depends on what book or what reference you're using. So if you look at the three matrices that are given below, again, they're filled with numbers. They can be filled with other things, variables, expressions, etc. But in this case, they're filled with numbers. Notice for our first example here, you have 3 rows. Remember, row goes from left to right. 2 columns. Columns go up and down. So this has 3 rows and 2 columns. So the dimensions would be 3 by 2. Simple as that. For example number 2, 2 rows, 2 columns. So this would be a 2 by 2 matrix. Now, just know that if the number of rows and number of columns are the same, then we call that a square matrix. That's more so for your own information, though. And then, example 3, 4 rows, 2 columns. So that gives you a 4 by 2 matrix. 4 by 2 matrix. So again, these are just examples of how to identify dimensions, because that's going to be important when we start getting ready to do some actual mathematical work to them, which we're going to do right now. So let us first start with matrix operations. So our first unit today focuses on adding, subtracting, and doing what's called scalar multiplication. So starting with adding and subtracting. When you're adding and subtracting matrices, you add and subtract their corresponding parts. So basically the parts that are in the same position. The parts that are in the same position with each other. But here's a big warning. You can only add or subtract matrices if the dimensions, so remember that's the rows and the columns, are the same. So if they're not the same, don't bother trying to add or subtract them. Don't even waste your time. Don't even waste your time if they're not the same. So in the case of these two, the very first thing you would do is check to make sure that they're the same size. So first matrix, you have 3 rows, 2 columns, so 3 by 2. Second matrix, 3 rows, 2 columns, 3 by 2. So Since the dimensions match, we could keep going. And by keeping going, we're just adding up the corresponding parts. So that would be 3, negative 6. 3 plus negative 6 gives you negative 3. 4 plus negative 3. 4 plus negative 3, positive 1. 5 plus 4, 9. And you would continue the rest of the way through the matrix until you were finished. You're simply just matching up the corresponding parts and doing the simple computation that goes with it. So with this second example, again, you check the dimensions first. If the dimensions work, you're good. If they don't work, then it's no solution. Here you have a 2-row, 4-column matrix. The second part of the problem, 1-row, 4-column matrix. Obviously, those don't match. Those don't match, no solution. So, no solution, not possible, something to indicate that that's not going to work. Something to indicate that's not going to work. So that's the basics of how adding and subtracting works. Now, multiplying, there's actually 2 types of multiplication. The first type of multiplication is what we're going to deal with now, and that's called scalar multiplication. The other type of multiplication is actually taking 2 matrices and multiplying them together. That's a little bit more difficult, so of course we'll be saving that one for a different lesson. That one gets its own lesson. But when you are multiplying a matrix by a single number, then that is known as scalar multiplication. You're multiplying by a single number, that's scalar multiplication. So to do this, simply multiply each number in the matrix by the scalar that's outside of it. So notice you have a matrix outside. So that means everything inside the matrix gets multiplied times 5. So this might remind you of distributive property, because that's literally all you're doing, is distributing. Now, I'm just showing you what it means, what this means. So would I necessarily expect you to show this work? No, but of course you should always be covering your own behind with regards to doing your mathematical work. And this is what you end up with as the answer. So scalar multiplication is fairly easy. You're simply distributing the number outside into the actual matrix. So these are quick examples of adding, subtracting, and multiplying. Well, adding and multiplying, the subtracting one didn't work. But now we're going to go through some more examples of adding, subtracting, and multiplying. We'll also go through a couple examples of when you have multiple operations in there at the same time. So when there's multiple operations in there at the same time, just know that order of operations still apply. Order of operations still apply. So let's start with example 1. Example 1, notice that it's an adding problem because there's a plus sign in the middle, in between the matrices. First thing you need to do is check to make sure that the dimensions are the same. If the dimensions match, you can keep going. If they don't match, unfortunately, that's a no, not possible, no solution. So you have 3 rows, 2 columns. 3 rows, 2 columns. Notice I didn't write R's and C's this time. You don't have to write R's and C's for everything as long as you know what you're doing. The dimensions match, so you can keep going. So in this case, that becomes 3 plus 0, 6 plus -1, -1 plus 6, -3 plus 0, -5 plus 2, -1 plus 3. So that's how the adding would work. Now all you have to do is just do it. So 6 plus -1 is 5. 1 plus 6 is 5. -3, -3, and a +2. And just like that, that's it. That's the end of the problem. Again, you're just adding the corresponding parts. For problem number 2, you're doing the exact same thing, so I won't go through that one step by step, but I will tell you that the answer, if you do it correctly, if you choose to give yourself the additional practice, would be 5, 6, 0, 3, -1, and 3. So again, basic interpretation of numbers. Basic interpretation of numbers. Let's do a couple of subtracting. Now these subtraction problems will actually work, unlike the last one that we had. For subtraction, again, check your matrices, make sure they work. 2 rows, 3 columns. 2 rows, 3 columns. They both match, so we can keep going. Remember, if they didn't match, then it's not possible, and we're finished. -5 minus 6. Remember, be careful with the signs. 2 minus -5. -2 minus -6. 4 minus 1. -2 minus 3. 0 minus -3. Again, this is the expanded view of what you would be doing. Now we get everything set up. -11, 7, 4, 3, -5, and 3. There's our matrices, and we're finished. There's our matrices, and we're finished. So in the case of example 4, again, won't do it for you, but here's the answers that you should get if you did it correctly yourself. Those answers end up being 2, 6, -3, -1. All set up and ready to go. Problems 5 and 6. Examples of the scalar multiplication. So again, scalar multiplication is multiplying, just multiplying. So 4 times that matrix is, now in this case the dimensions don't matter. You're just taking everything, multiplying it times 4. So 4 times -4, 4 times 3, 4 times -5. It's -16, 12, -20. That's it. So if you look at problem 6 again, just give you the answer for that one. -25, -30, +20 in the first row. and then negative 20, 10, and 5 in that second row. So scalar multiplication, just multiplying through. So 7 and 8. So 7 and 8 are both problems that involve multiple operations. They involve multiple operations. So one key thing to keep in mind here, first off for problem 7, as it'll show up like this on your note sheet, first one is a minus and the second one was a plus, just so that there were two different operations. But the main thing to keep in mind here is that good old order of operations that you learned in Algebra 1. Good old order of operations. So that's, please excuse my dear Aunt Sally. So remember, adding and subtracting, you work from left to right. You work from left to right. Those same rules, those same conventions, apply when you are working with matrices. So nothing changes. Nothing changes. So let's look at problem number 7. So 7, we're subtracting and we're adding. So remember, we add or subtract from left to right. So we're going to work with those two matrices first. It's a subtraction problem. So that gives you 5 minus negative 6. 5 minus negative 6. 3 minus 0. 5 minus 1. And then 1 minus negative 4. Sorry for the interference in the board. So the last matrix we won't touch for a second. We solve that out. That gives you 11, 3, 4, and 5. We add it to the matrix that was left over. Now we add the answer to the matrix that was left over. 11 plus 5, 16. 3 plus 4, 7. 4 plus negative 2, 2. 5 plus negative 6, negative 1. And there's your answer. Again, key thing, work from left to right. It's still working from left to right. Then last example, problem 8. So notice you're adding, but you also have a number in front of a matrix. So that's adding and scalar multiplication. So, of course, multiplying comes before adding and subtracting. So we still follow our order of operations. So 3 rows, 2 columns, 3 rows, 2 columns. Again, check your dimensions, make sure that they're valid. We do our multiplication first. So this first matrix is just going to come down for the right, come down for the party, plus 5 times negative 4, negative 20, 5 times 6, 30, 5 times 1, 5, 5 times 1, 5, 5 times negative 4, negative 20, 5 times negative 1, negative 5. So everything is there and ready to go. Now we add the two matrices up. 1 plus negative 20, negative 19. 1 plus 30, 31. 6 plus 5, 11. Negative 4 plus 5, 1. 0 plus negative 20, negative 20. 0 plus negative 5, negative 5. And you get your answer. And other than that, that is that. That's the baseline introduction to a matrix. Knowing how to tell how many rows and how many columns, knowing how to add, subtract, and scalar multiply. Remember, it's scalar multiplying. Multiplying two matrices together is its own section because there are a few more rules that you have to keep in mind. So we'll get to that in its own due time, but that concludes this first lesson on matrix multiplication. Have a good one.